Hello and welcome. So we'll be solving another example on point of contraflexure. All right. So the first thing we are going to do is to consider the summation of upward force to be equals to 0, and then we'll be taking our upward force to be positive and our downward force to be negative. All right. And our upward force is here is the reaction at A. So the sum of reaction at A plus the sum of reaction at B will be equals to the sum of the downward forces. That is 800 plus 2000 plus 1000. Alright. So reaction at A plus reaction at B will be equals to 3800. 3800. So if we make RA the subject here, I'm going to have our reaction at A to be equals to 3800 minus reaction at B. So let's call this our equation number 1. Alright. So the next thing we are going to do is to take moment about point C. So that is sum of moments about point C will be equals to 0. Alright. So we have already set upward force to be positive, downward force to be negative. It means the moment produced by upward force and the moment produced by downward force will also remain as positive and negative. All right. So for upward force, now let's start with this. Since we are taking our moment towards point C, so it means RA, moment is force times distance. That is RA multiplied by what? The total distance. So we are going to have RB rather multiplied by the total distance here is 8 plus 3, which is 11. Yeah, which is 11, plus RA, which is going to be multiplied by the total distance, our RA, that is 3, which is going to be equals to 1000 multiplied by total distance. The total distance is 13 plus 2000 multiplied by total distance. Here we have 5. From here to here is 5. From here to here is 3. That is multiplied by 8. Alright. So here we are going to have 11 RB plus 3 RA will be equals to 13,000 plus 16,000. Alright. So 11 RB plus 3 into our RA is 3,800 minus RB, which will be equals to, if we sum this together, you are going to have 29,000. All right. So now the next thing is we are going to clear the bracket. So we are going to have 11 RB plus 3 times 3,800. So if you multiply 3 times 8,000, you get 11,400 minus 3 RB equals to 29,000. All right. So if you collect the like terms, RA minus RB, that is 8 RB, which will be equals to 2,900 minus 11,400. So if you do that, you are going to have 17,600. All right. So if you want to have your RB, we divide both sides by 8. Then our RB will be equals to 2,200. Newton. All right. So for us to get our RA, we subtract 3,800 from RB. So that is 3,800 minus 2,200. So our RA, that is our reaction at A, will be equals to 1,600 Newton. All right. So now the next thing we are going to do is the shear force calculation. All right. So the shear force at point, we're starting at point E. All right. So if we start at point E, to your right hand side, we only have one force. And don't forget, downward force is negative, which is a downward force. So this is going to be negative 1,000 Newton. So the shear force at point B, if you start at point B to your right, we have two forces, a downward force and an upward force. That is minus 1,000 plus RB, and our RB is what? That is 2,200. So if we sum this together, we are going to have 1,200 Newton. The shear force at point D. Alright, so if you stand at point D, we are going to have three forces. This and this, we have added them to give us 1,200. So, and the next one is a downward force, so which is going to be minus 2,000. So that is going to give us a negative 800 Newton. Alright, so the shear force at point A, shear force at point A is going to give us, we have four shear forces like that. So this has been calculated, and it is nothing but what? Negative 800. Alright, negative 800. And if we now add the effect of this upward force here, which is RA, our RA is 1,600. So if we add that, we are going to have 800 Newton. Alright, so the last but not the least is the shear force at point C. Shear force at point C will be equals to, alright, so don't forget, we are going to have how many forces? Four forces, and we have added all their effects, which is what? 800. So, and I'm going to add the effect of the, which is a downward force, that is minus 800. So this is going to be 0 Newton. So we are done with calculation for all the shear forces. Alright, so now let's go for the bending moment calculation. Alright, so the bending moments, this is an overhanging beam. Once you have an overhanging beam, you should note that the bending moment at the free end is nothing but what? 0. So the bending moment at point E will be equals to 0, and the bending moment at point C will also be equals to 0. So by law, starting from this side to that other side. So let's go for the bending moment at point B. So the bending moment at point B, don't forget, moment is force times perpendicular distance. That is, and don't forget our downward force is negative. So we are going to have negative 1,000 multiplied by total distance, which is 2. So minus 1,000 multiplied by 2, which is going to give us minus 2,000 Newton meter. Alright, so the next one is the bending moment at point D. Alright, the bending moment at point D, we are going to have negative 1,000 multiplied by total distance. Don't forget, from here to here, we don't know it, right? But we know that from this place to this place is 8, while from this place to this place is 5. So this place is going to be 8 minus 5, which is 3. 3 plus 2 is 5. So it's going to be multiplied by 5. Alright, so now this times this, then plus, because this is an upward force, RB, plus our RB is nothing but what? 2,200 multiplied by total distance there, which is 3. So by the time you do your math, you are going to have your bending moment at point D to be nothing but what? Bending moment at point D will be nothing but 1,600. 1,600 Newton meter. Alright, so the bending moment at point A. Alright, the bending moment at point A, if you stand at point A here, from this point to this point, from this point to this point, while from this point to, so negative 1,000 multiplied by total distance. We're going to have negative 1,000 multiplied by total distance there, which is 10, plus our upward force, that is RB, that is 2,200 multiplied by total distance there, which is 8, then minus 2,000 multiplied by 5. Multiplied by 5. So if you do your math carefully, all of this stuff is going to give us 2,400, negative 2,400 Newton meter. Alright, so and the bending moment at point C now will be equals to 0. Alright, so now the next thing we are going to do is to draw our line. So we want to draw the shear force diagram and the bending moment diagram. All right, so we are going to be drawing the shear force and the bending moment diagram. So this is our reference line for our shear force diagram. Above this line is positive, below is negative. This is the reference line for our bending moment diagram. Above this line is positive, below is negative. All right, so the shear force at point E is negative 1000. So let's put our here to be negative 1000. All right, so this point here is our negative 1000. So and between E and B we don't have any other force, so we are going to be drawing a constant line here. All right, so the shear force at point B is nothing but what, 1200. So let's take this point here to be our 1200. So we are going to be joining these points with these points. All right, and between B and D we don't have any other force, so we'll be drawing a constant line. All right, so the shear force at point D is nothing but what, negative 800. All right, and don't forget this one is from this point, this one is 1000, right? So 800 will be somewhere around here. All right, so and between D and A we don't have any other force, so we are going to have a constant line. All right, so the shear force at point A is positive 800, and don't forget this one is 1200, right? So 800 will be somewhere around here. So join this point to this point. So and from this point to this point we don't have any other force, so we are going to have a constant line. All right, so and don't forget shear force at point C is 0, so we are going to go back to 0. All right, so this is how it's going to be, so you can shade. All right, so this side is negative, this side is positive, this side is negative, this side is positive. All right, so that is our shear force diagram. Now let's go for our bending moment. So the bending moment at point E is 0, so that is 0. The bending moment at point B, the moment at point B is negative 2200. So let's take this place to be our negative 2200. All right, so negative 2200. So we'll be using an inclined line, because since we have a constant line, so we'll be using an inclined line to join the 2 points together. All right, so the bend moment at point D is 1600. All right, so let's take this point to be our 1600. All right, so we are going to be using an inclined line to join this point with this point as well. All right, so the bend moment at point A, is negative 2400. All right, this one is 1200. Sorry, this one is negative 2000. So 2400 we go a little bit down. All right, so we use our inclined line to join this point and this point. All right, so and then when we're at point C is 0, so this is 0, so we use an inclined line to join this point to this point as well. All right. So as you can see, we are going to shade. All right. All right. So this is negative. This is negative, and this is positive. All right. All right. So that's it. So we are done with the bending moment and shear force diagram. All right. So now we want to find the point of contraflare. We said our point of contraflare is the point where bending moment is equals to 0 as it changes its sign from either positive to negative or from negative to positive. All right. So if you check our bending moment diagram, you will observe that all this point here is negative, but it starts to change to positive at this point. So from this our first point of contraflare here, and again this is a positive here. From this point now it goes towards negative. So this is another point of what? Contraflare. So we have 2 points of contraflare. There's a situation we can have 3 points of contraflare. It depends on how the question and the diagrams look like. And there's another point where you will not have a point of contraflare. All right. So here is the first point of contraflare, and here's another point of contraflare. So we are going to be drawing a straight line up all right. So here's another point of contraflare. So this is just how you can go about this question. It's very interesting. All right. So now you know, when you are calculating your bend moment, either you calculate to the left or to the right. All right. So to make your work very simple here, this is you can say this is your first point of contraflare if you like. So from this point we have our point of contraflare here. So we can take a distance to this force that we have here, and for this other one that we have here too, we can take another distance to this force that we have here. So let's take a distance from this point to this point. So let's take a distance. Let's take a distance from this point to this point. Let's call it to be our x1, and from this point to this point, let's call it to be our s2. All right. So this is s2. All right. All right, so we'll be starting with the point of contraflare now. We have taken from this point to this point to be our x1. So at this point now, to start at this point, we are going to you can from this point now, is either you calculate your bending moment towards this side, or you can calculate towards this side for the point of contraflare anyhow. So for me to make my work easier, I have taken my distance from this point to this point to be x1. So I want to calculate my bending moment towards this side. So the first point of contraflare. So let's say point of contraflare. All right. So the first point of contraflare, if we stand at this point, we're going to have 800. Don't forget this 800 here is a downward force. Is a downward force. So let's say bending moment B1 will be equals to, we have negative 800 into what will be the distance. The total distance is going to be 3 plus what? x1. That is 3 plus s1. All right. So again, we have an upward force here, which is RA times what? s1. So we are going to have plus RA times s1. All right. So now, but don't forget that our RA is what? 1600. So, and For our point of contraflare, our bend moment at this point 1 must be equals to what? 0, because we say contraflare point is the point where bend moment is equals to 0 as it changes its sign. Alright, so now this B1 will be equals to 0, and we are going to substitute for ROA. So we are going to have negative 800 into 3 plus S1 plus ROA. Our ROA is 1600. S1 equals to what? 0. So if you clear this bracket, and 800 multiplied by 3, you are going to have nothing but what? 2400. So 2400 plus 800 S1 plus 1600 S1 equals to 0. All right. So this plus this is going to give us, sorry, this is going to be negative, because negative 800 multiplied by S1 is negative 800 S1. So if we add this with this, we are going to have 2400 plus 800 S1, which will be equals to 0. All right. So if you move this to the other side, we are going to have 800 S1 to be equals to 2400. So for us to get S1, we divide both sides by 800. So, and our S1 will be equals to what? 3 meter. So the first point of contraflare is at 3 meter from what? From point A. All right. So the second point of contraflare, I'm going to have BM2, which will be equals to, all right. Now look at this. So if you start at this point, so this is the point, is either you calculate towards this side or you calculate towards this side. All right. So for us to do that, you are going to have, so we are going to have, okay, let's calculate towards this side, because it makes sense. All right, so here we are going to have negative 1000 multiplied by total distance, that is 2 plus what? S2. So we are going to have minus 1000 into 2 plus S2 plus this reaction at B, then plus what? Reaction at B multiplied by what? S2. All right. So now, don't forget again, our bend moment at this point 2 will also be equals to 0, because we said point of contraflare is the point where bend moment is equals to 0 as it changes its sign. All right. So here we're going to have negative 1000 into 2 plus S2 plus our ROB. Our ROB is 2200. So 2200 S2 will be equals to 0. All right. So if you clear this bracket, we are going to have minus 2000 minus 1000 S2 plus 2200 S2 equals to what? 0. All right. So we are going to have minus 2000. If you do this math, you are going to have plus 1200 S2 equals to 0. So if we move this to the other side, I'm going to have 1200 S2 will be equals to 2000. All right. So for us to get the value of S2 here, we divide both sides by what? 1200. All right. So it means the value of S2 will be equal to 1.67 meter from what point? From point B. All right. So the first point of contraflare is 3 meter from point A, and the second point of contraflare is 1.67 from point what? From point B. So this is how to solve a question where we have on a case where we have 2 points of contraflare. Thank you. I believe you understand this. Peace out.